Hello everybody, my name is Devashish Roy. I'm the Senior Network Trainer as well as Cisco Networking Specialist at the Indian Cyber Security Solutions, and these are my LinkedIn and Twitter contact informations. Today I'm going to discuss about EIGRP Successor and Feasible Successor. Now EIGRP, Enhanced Interior Gateway Routing Protocol, by default supports load balancing across equal cost paths, that is 4 equal cost paths. Means if the metric of 4 paths are equal or exactly the same, EIGRP will load balance, means it will send packets to all 4 routes. And also the load balancing can be done over unequal cost paths also. So the EIGRP can load balance across unequal cost paths. It can go up to 6 unequal cost paths, and now in case of improved modern iOS, it can go up to, say for example, 16 paths also. Successor route, it is the best path to the destination. So it has the best metric. And the feasible successor is the alternate path or the backup path. You can say the backup route to the destination. Feasible distance or FD is the metric of the successor route. So the best path metric is known as the feasible distance. This is the lowest cost path. This is the best metric, you can say. And reported distance or RD, or we can say advertised distance also, that is a metric advertised by each neighbor router. To qualify for feasible successor route, the reported distance should be less than the feasible distance of the successor. So that is the condition to be a feasible successor, that is the RD should be less than FD. So this is the example diagram. Router E to router A, or network X is connected to router A, and we can see router E, CA, that is a path. Again router E, BA, that is another path to reach the network X. Again the path EDA can be taken. So who will be the successor and who will be the feasible successor? The calculation will be like this. If you go to router B route, the feasible distance will be 30. Means the distance from the router E to router A through router B will be 20 plus 10, that is 30. Through router C it would be 10 plus 10 or 20, and through router D it will be 20 plus 25 means 45. Just this is written as the feasible distance. So what is the best path or best metric? That is definitely through router C, because the feasible distance is 20 compared to 30 or 45, it is lower. So the route through router C will be chosen as a successor route. And the reported distance through router B, it is 10, router C it is also 10, and through router D it is 25. Just as you can see in the figure, through router B is 10, router C to router 8 is 10, and router D to router 8 is 25. So the condition was the RD should be less than FD. So the FD, that is the successor routes metric, is 20. And the reported distance of route through router D is 25. So it doesn't qualify to be a feasible successor. But router B does qualify because its reported distance means 10 is lesser than the successor route's feasible distance 20. So the route through router B will be chosen as a feasible successor route. So this is the theory part of the successor and feasible successor and EIGRP load balancing, and now I'm going to show you this thing in practical using GNS3. So in GNS3 we have these routers, router 1, 4, 2, 5, and 3. Now I will configure IP addresses. Now this link router 1 to router 4, this is fast Ethernet, this is also fast Ethernet, but router 1 to router 2, this is Ethernet link, and router 2 to router 3, this is fast Ethernet again, and router 1 to router 5, this is serial connection, and router 5 to router 3, that is the fast Ethernet port. So you can see the port numbers here. Port number 4 by 0 is connected to 0 by 0, and here it is fast Ethernet 0 by 0 to 4 by 0, and here 0 by 0 to 5 by 0, and here fast Ethernet 0 by 0 to 0 by 0, and here also the Ethernet 3 by 0 to 3 by 0 normal Ethernet connection means 10 Mbps, and this serial port means 1 by 0 to 1 by 0 serial connection. So let's configure the routers. Let's give the IP address, and also I will configure my destination, and that is a loopback interface on router 3, and give a IP address. So we'll reach router 1 to router 3, and we'll see the topology table of EIGRP that will show us the successor and feasible successor. Interface, that is, first this, say this interface, it is fast Ethernet 0 by 0. You can use classless also, because EIGRP uses the classless routing. Now this connection is connected as 4 by 0 to 0 by 0. So this is also a fast Ethernet connection. So let's configure it. Say 12001. Also on R3. It would be 12002. Now let's configure this Ethernet port, Ethernet 3 by 0 to 3 by 0, and this connection, that is a 0 by 0 to 4 by 0 fast Ethernet. Yes, Ethernet 3 by 0. Say 13001. Router 2. In 002. And also this connection also will be configured, that's 0 by 0 to 4 by 0. Faster than 0 by 0. Say 14001. To this connection means to the 4 by 0. 14,001. So this will be 14,002. And lastly, this is a serial connection. Let's configure the serial 1/0 to 1/0. Say 15,001. Pin 002 on the Ethernet link, and also this is a fast Ethernet connection. There is a fast 0/0 to 5/0. So 16,001. And on router 3 interface fast Ethernet 5/0. Say this IP address will be 16,002. Now let's configure EIGRP on all the routers. But first, before doing that, let's configure a loopback interface also on R3. Like 0 IP address, it will be 5.0.0.1. This would be our destination. Now configure EIGRP. Now auto summary to stop the auto summarization routes, and the network 0.0.0.0. Every network will be included, and all the other routers do the same thing. Adjacencies are building. Then router 4, also the same thing. And also router 5. And also on router 1. Now from router 1, our objective is to go to that 5001, that network. So now the command show IP route EIGRP. You can see that 500 network. The command show IP route, then say 5000. So this is showing you this is the best path or the successor route, that is 11 through 11,002, and this is the route metric. That's the feasible distance of this. This is the feasible distance, is a successor route. Now give the command show IP EIGRP topology. Yes, 5000, that, and see through 11002. So this is a composite metric, and this is the feasible distance of the successor. This is a FD and this is a RD, and also the other two routes through 13002 and 15002 is also shown. Why? Because their RD, because this is their RD 156160. It is lesser than the feasible distance of the successor route 158720, and this also 156160. Same, this thing, this RD is also lesser than the successor route's feasible distance 158720. So this is our successor route through 11002, and this is the feasible distance 158720, and the other two via 13002 and 15002 are feasible successors because their RD 156160 in both cases are lesser than the 158720. So they qualify for the feasible successor. So that is it that I was going to show you in this video about the successor and feasible successor of EIGRP. So I hope it was informative for you. I hope you have enjoyed it. And some other day I will come with some other topic. Till then, it's goodbye.